Hello, so we're going to go through an example here where we discuss whether the following functions are injective, surjective or bijective. And you've already learned the definitions of those, but let's give ourselves a quick cheat sheet on how to test it from a graph. So we know that injective, which means one-to-one, it means that every input has one and only one possible output. So if we draw a horizontal line through the graph, a horizontal line will cut the graph either 0 times or once, one time. It will never cut the graph twice. Okay, if you have 2 cuts from a horizontal line, it means that there are 2 different inputs that could give you that output. Okay, a quadratic is a good example of that. Okay, so there are 2 different inputs that could give you an output of 4 here. For a surjective is described as onto, as we learned. So a horizontal line must cut the graph at least once. So the horizontal will cut the graph once or many times. It can cut it several times, but it can't cut it more than once. And finally, a bijective is both. A bijective graph, a horizontal line, any horizontal line will cut the graph exactly once. So to be bijective, you can't cut the graph more than once and you can't cut the graph less than once. You must cut the graph exactly once. So if we look through these different functions here, we're being asked whether the function is injective, surjective or bijective, and we'll use the horizontal line test. So looking at the graph here, this horizontal line, it's cutting the graph once. It's definitely not going to cut it twice, and so on and so forth. I'm just skip over this for a moment. Once, and all the way down here, it's always going to cut the graph. But what's going on here? We've got a horizontal line. What we have is a triple root here at x cubed, and it's only cutting it once there as well. So every horizontal line cuts the graph exactly once, and therefore this function f of x is bijective. It never cuts it 0 times and it never cuts it more than once. Let's look at the next example that we have here. So straight away we can see if we draw a horizontal line up here, we're cutting the graph twice. So we can rule out injective, and as soon as we rule out injective, we rule out bijective as well. The question then is whether it is surjective. Is there any horizontal line I can draw that never cuts the graph? And there is. A line down here will never cut the graph. So this function is neither, it's none of, it's neither injective, surjective, nor bijective. It can't be bijective if it's missing either one of these, because the line y equals 4 cuts the graph twice, meaning that we have two inputs for that output, for y equals 4. So that means it's not injective, and the line down here through y equals -1 never cuts the graph. Never cuts the graph, which means we have no input for that value. A lot of the time, however, we'll restrict our range. So if I restricted my range to f mapping the real numbers onto the real positive numbers, so in this range, I'll just make a note on that. It wasn't the question as asked, but if you got asked this question, with this restricted range, with this range, f is surjective. Still not injective because of this line here cutting the graph twice, but it is surjective if you restrict your outputs to the positive values only. And that's the kind of question, actually, even here we'd have a problem there, right? 4, 3, 2, 1, 0. No, that's right on the graph, yeah. So if we restrict our range, that will work. Let's look at the next one here. So straight away I can see that I can draw a line, a horizontal line here, that will never cross my graph. Okay, so I have a line which never cuts the graph. And it's sufficient to draw it on the diagram and give your explanation next to the diagram like this, a line which never cuts the graph, so therefore it is not surjective. Okay, so that's not surjective unless we restrict our range. What about here though? Cuts it once. It cuts it once. So we can see no line ever cuts the graph more than once. So it is one-to-one. There's no output that has two inputs, two different inputs. So therefore it is injective. Okay, here's another cubic function down here. Every line will cut the graph, okay, because that goes on forever in both directions. So every line will cut the graph. Will cut the graph at least once. And it is surjective. Is it injective? Some lines, so I can draw a line here, for example. Some lines will cut the graph more than once. Some lines, for example, y equals 0, cut the graph more than once. So therefore, it's not injective. And if it's not injective, it can't be bijective, because bijective, bi meaning two, means it has to be both of those. Okay, let's look at the last part of this example. We have the exponential function here. And you'll notice the restricted range. So this is a little bit like what I was talking about in part 2. So within my restricted range, every horizontal line cuts my graph once, and it never cuts it more than once, and only once. So exactly once. So therefore, this is both injective, it's never cutting it more than once, and bijective, it always cuts it at least once. And that means, sorry, injective, and what I meant to say there was surjective. And because it's both, it's therefore bijective. So my graph is both injective and surjective. Let's write this in pencil. Tipex doesn't take pen well. Surjective. Okay, so that's the horizontal line test for determining whether graphs of functions are injective, surjective, or bijective.